Okay. Okay, now this is a problem which you should get right, because we had enough practice and this is by no way a difficult problem. This is A and this is B. Suppose A weighs 100 Newton and B weighs, suppose 200 Newton. Now what's happening is some force F is being applied on block B. Now the question is, what should be the minimum value of F so that the block B slides from beneath the block A? Coefficient of friction. Coefficient of friction, suppose, is given as 0.25. Mu is given as 0.25 between all the surfaces, between B and the ground and between A and B. So it's 0.25, and now you have to find the minimum amount of force so that the B slides beneath A. This is a string. This is not going to break, so A is going to stay there. Okay, now I'm giving you the answer and just check yourself that what you have been learning in friction. The answer is the minimum amount of force would be 90 Newton. If you got this, you are brilliantly doing fine. But let's discuss how we're going to get to this number 90. Let's see. Now, if B is going to slide beneath A, then the limiting friction is going to act between A and B. So limiting friction is going to act on B in backward direction between the contacts A and B, and so will be the case between the B and ground. So if we are looking at the value of the friction between the contact A and B, then limiting friction is going to act on B in backward direction because B is going in forward direction. So the direction of limiting friction on A will be towards our left. So if you're going to draw the FBD of A, then this is the direction of force, friction, this is tension, and you have normal reaction. If you look at the horizontal component, then a component of tension and friction is going to come. Normal reaction will be perpendicular. Now we can say that the friction is acting on A in leftward direction, but still A is going to remain there stationary because the horizontal component of tension is towards right. Tension acting away from the body, it will come towards right. So the horizontal component of tension is towards right, and that horizontal component is T by root 2. Now this T by root 2 should be equal to the friction force because A is not moving, it is tied up with the string. So this horizontal component of tension should actually balance the friction force acting on A. The friction force acting on A is mu 1 by 4 into N, normal reaction. Now normal reaction will be 100 mg minus the vertical component of tension. Easy to see that through. So this is the value of tension. Now this value of tension would come out as so tension from here you can see is coming out as 20 root 2. Tension is 20 root 2. Fine. So that means the value of friction between A and B is going to come out as 20 Newton. Okay. This is less than limiting friction. Limiting friction would be 25 Newton because the normal reaction is not maximum. Apart from normal reaction, you have a tension force acting vertically. So normal reaction actually has been reduced. So the value is less than mu mg. Mu mg would be 25. Okay, so the force of friction we have found between A and B as 20 Newton. Now what you have to do is you have to find the force of friction between B and the ground and both will be towards right, oppose the motion. So summation of both will be equal to F. So all you have to do is find the force of friction between B and the ground. Force of friction between B and ground will be